Good afternoon, everyone, and welcome to the Building Financial AI Agents with Bigdata.com webinar. I'm Adelaide. I'm here with Aakarsh Ramchandani, our Chief Product and Strategy Officer, and Alexander Walsh, our VP of AI Product. A little introduction on both our presenters today. Alex brings 10 plus years of investment experience from both sell side and buy side, now applying that experience to building the AI tools for finance professionals. And Aakarsh has spent a decade building search systems for unstructured financial data, building multiple trading systems at various hedge funds. He's lived in the shoes of every team building search and screening tools and created Bigdata.com to solve the problem at its core, running actual financial searches at scale with proper reference data. So in this session, Aakarsh will showcase our recently launched DeepResearch Agent within Big Data. We'll also give you an introduction to the Bigdata API, and Alex will show you how to easily build searchers using that API. And then we'll abstract on top of that to demonstrate just how to build a DeepResearch Agent. Just a couple of quick housekeeping notes. We will do a Q&A at the end, so drop any of your questions in the chat as we go or submit them anonymously in the Q&A window. I'll also be sharing links throughout the conversation, and all of the code from today will be in our GitHub repo, and I'll share that as well at the end. So by the end of the webinar, you'll know how to build financial AI agents on infrastructure you actually own with full transparency and 20 plus years of premium financial data. All right, Aakarsh, show us what's possible.
Thank you so much, Adelaide. And thank you, everybody that's joining on the webinar. I cannot see the list of attendees, but I'm hoping that you're there. It's a real pleasure to walk you through what I've been doing for a while and what we've been building here to help you guys accelerate your AI agent strategy. Before we go into the technical details of the webinar, we wanted to just share with you that we recently launched our DeepResearch Agent in alpha last Friday. This is available on bigdata.com. What I wanted to do for a quick second here is we're going to quickly show you what that DeepResearch Agent actually looks like. And hopefully by the end of this webinar, you would have a lot of insight in how you can build something very similar to yourself. So Alex and I were debating this actually last Friday as an investment for ourselves, which is on a second order effect on what's going to happen with the adoption of AI. So we decided to just write me a deep dive report on how the demand for memory is expected to grow with the adoption of AI. One of the instruments that we were looking to invest in was Micron. So I'm going to hit go here. And this is a live demo of a DeepResearch Agent that is working on the big data search APIs in the background. As this is happening, what I wanted to walk you through is a little bit of the architectural decisions we've made in the backend. Some of you are clients of ours, some of you are prospects of ours. What we've done in the backend in the last quarter is we've re-architected our entire system to operate with this notion of tools. So we're launching our new API, which is a RESTful API. This will be available for you to access via API keys. You can wrap these APIs in tools, and in a LangGraph, AutoGen, whatever framework you're actually using, you can call into these tools and you can have a React style agent that answers a question, retrieves some documents, has the full citation, reflects on the answer, sees if it has enough information, and then continues to ask more questions. So what you are seeing here is a full search chain or a thought chain of all the different questions that were asked by the agent, all the different sources that you have, and you get a long form report that answers all of the questions. Now, what's interesting about this is everybody has asked us about the citations. Citations are coming next week. We've been trying to figure out how to do inline citations on DeepResearch. This is something that is a little bit harder than we expected, but it's launching next week. You will be able to ask questions. You will be able to ask follow-up questions into all of this. And hopefully by next week, it'll be in beta. So if you have a bigdata.com account, you can go and test it out right now. If you want to really stress test it, you can send it a 2-page prompt and just watch it go for the next 30 minutes and produce a 10-page report for yourselves. So with that, I'm going to hand it over to Alex, who's just going to walk you through a little bit more of the technical side of things.
Thanks, Karsh. So what you just saw was deep research running through a query. And effectively how deep research works is it takes your query in, it builds a set of subqueries, it then takes reflections, and effectively it goes through this looping logic that incorporates tool use. And a very important part of building any agent, which is we're going to show you how to build step by step today, is that core tooling layer. And within that, the most important thing that we think for grounding LLMs and preventing them from hallucinating is search. So that's ultimately what we provide with the Bigdata API. It is a high precision search API that's built on an enormous content store of more than 1.5 billion content chunks across 100 million documents and more than 15,000 premium sources across news, filings, and transcripts. We ingest all these documents in real time and put them through a detailed document pre-processing engine, which involves chunking, sentiment analysis, and entity detection. Then with those entities, what we do is we map them to a detailed knowledge graph that shows you related entities, products, topics, and many other things within that knowledge graph, which then allows you to then query that and get to what you're looking for precisely. To give you a sense of what this looks like, I'll flip over quickly to our knowledge graph here within the Big Data app. So if I open a watch list and go into the advanced menu here, we can see that we have more than 7 million companies that are mapped within our knowledge graph, as well as more than 4.5 million people, places, products, and other things as well. And every one of these entities you can then find and search within the Big Data API. So moving over to the API documentation, the core part about big data is not just about content, which we have an enormous store of content that's updated in real time. It's also about control. And the big thing with control is that you're able to conduct searches, which is the core part that's underlying these agents, with a very high level of precision. And the way you can do so if I go to query filters, you can search for any entity that we have within our knowledge graph. You can also search for individual or watch lists, which are lists of entities that we have within bigdata.com. You can search for topics. You can limit the searches to individual sources, as well as run for specific keywords and similarity on those keywords. And what we find is that if you want to then query across documents, there's many different things that you can then filter for, including positive or negative sentiment. You can dial up or dial down how precise you want your search to be with re-rank or search. And as I mentioned, you can then now filter for specific sources. So if, let's say, you just want to get press releases or you just want to get, let's say, hedge fund newsletters, you can then dial into those specific sources and build a workflow on top of that. Cool. So that's essentially the background on search. Rather than just show you the documentation, we thought it'd be good to walk through a specific example of how to get started and build a search yourself. And one of the easiest ways to do so is with our recently launched MCP server. So MCP stands for Model Context Protocol. And this is a framework that was recently launched, or was launched last year by Anthropic. Just set it up. Yeah. So it's essentially what MCP allows you to do is it allows for interoperability between your language model of choice and third-party tools. So effectively what we're going to demonstrate is how you can then build a series of files that will perform a search on the API just using natural language. So you don't need to go ahead and write specific code. You can just do that using your MCP integration. So here I'll jump over to Claude, which you could use ChatGPT, or you could use Cursor, or you could use many other MCP clients. I prefer Claude because it's our Claude desktop because it allows me to write files directly on my desktop. And I've taken the same query that Aakarsh just showed, or a very similar one to it, which is to use the MCP Big Data MCP server to help me search or help me learn about the demand for memory, how it's expected to grow with AI, I'm particularly interested in searching for the impact on Micron. And I want to use, so I give it a little bit more detail here, which is I want to use our auto suggest function to find the entity. Then I want to perform a search for both the entity of Micron as well as other related terms here. And I don't even have to give it the specific terms. I can just give it the description here within Claude. If I hit this and hit run, so I've also given it a little extra information about my credentials to allow for minimal config needed. And I want to save it specifically to this folder of Micron search new. So on my desktop, I have this folder set up already. There's nothing in it, as you can see. I also have an IDE that's sitting here open to this folder as well. So you could again see there's nothing here. And once I hit run on this, essentially this language model is going to go off and build a series of files on my behalf. So let's hit run and see what happens. Great. It's already getting started. We can see here that it is taken 1 second to go to our API documentation. It's going to continue to do a number of different things. Eventually, we'll see it start building some documents on the right. So this does take a few minutes. So while it builds this out, what we're eventually going to see as this gets completed is we're going to see these documents get built into this folder here. In the meantime, I thought it'd be helpful to show you how you can set this up yourself. So if you go into our API documentation, there's a tab here called MCP reference. And if you scroll down, essentially it describes what MCP is and how to use it. But there is a single line of code here, this npx mintmc docs.bigdata.com. If we copy this and paste it into our terminal, which I've done here, and hit run, this is going to set up the integration between whatever our LLM is of choice and big data. So here it asks me which one I want to select. I'm just going to select cursor. And if I open up my terminal here, so you can see a little bit more, it's now returned me this series of JSON here, which is what I need to then configure my MCP server. So once I hit copy, I'll move this into my config file. So I'm going to hop back over to Claude, see how it's going. It's still progressing. It's starting to write some files. We can see it's progressing on my behalf. And if I go Claude, settings, developer settings, edit config, this will open this file Claude desktop config, open this up, which is here. And then by pasting this into this document and restarting my Claude, it will then have access to the entire documentation that you have here in the previous tab. So since I've already done that, I can close this out, jump back to this file. And we can see here that it's making good progress. It's now starting to build out some detailed documents. It's built out the directory. We can see what's in here now. So it's already built this Micron AI memory research.py as well as requirements.txt. It seems like there's still probably about another minute left. So in the meantime, I can show you a few things within the documentation. There we go. Great. So within the documentation, one of the core things that I mentioned earlier was the auto suggest feature. And actually, this is a really important function if you're just getting started with the Big Data API, because what auto suggest does, it also is similar to find companies, is that if you're looking for a specific entity that you might not know the RavenPack identity to, you can run one of these searches to then find the RavenPack identifier, which is often like this. And then you can use that in any of your search configurations. So then you can combine that with either a similarity search, a keyword search, or many of the other filters that I mentioned before. Another really powerful feature is co-mentions, which if you come to search results, manage searches, and I believe it is...
It's right above that.
Oh, right. Yeah. So co-mentions is a really powerful one as well, because then you can search across for a specific entity or a specific topic. You can also find what other entities are then mentioned in the same chunks. So you can start building a map of relationships across different ideas, concepts, themes. Whenever doing thematic research, we find this is a really powerful tool that we use a lot. I think Claude should be done by now, so let's just check on the progress. great. It looks like it is done. And if I open this folder back up, we now have 5 files that have been built here in live time, all today at 2:15. A requirements.txt, a README, a quick start. And if I jump to this in cursor, we can see, okay, great. These things are open. So the README here is explaining what I need to do to now run this. So if I clear, I'm going to drop in the pip install requirements.txt. My requirements are now installed. And what I can do now is then run this Python file here. To avoid from live demo issues, I've done this just beforehand here, which is the same file that I've just run. You can see it's a duplicate. So I can quickly go Python micron AIS research.py, hit run. Now what this is doing is if we go through the code base here, it is first setting up our big data client. It is then configuring a series of searches. And so Claude just wrote this file for us previously. And this is what it's doing. So we can see that it's doing a number of different searches, finding different files that are relevant for my query. It's going to the knowledge graph, getting Micron technology, so it correctly finds the right identifier. It then combines those identifiers with a series of other searches. So here the AI has then come up with a number of different terms to search for. And then it runs those and puts them all into this big Excel file, which Excel doesn't show within cursor. So I have moved this over to a new file here. And so this is what the output of our searches typically look like. You can see here for that particular search, we've now fetched over the past 6 months 421 individual chunks across news, filings, transcripts, and research. Each of these chunks, we have the specific bit of text that's relevant. And we also have a number of different scores. So I've ranked them based on relevancy score. So for the specific queries that we're running, so for instance, the query here is memory semiconductor AI market growth. We have then the specific commentary that was in that document. So this is pulling from news, but there are also other ones in here that are pulling directly from filings and transcripts, which I can, what's our news, but here we go. So here's one pulling from the latest earnings call. And we can see here it's talking specifically about the growth of the specific types of memory and how it's moving. In each of these, we also have sentiment, and we also have a document ID, which I believe is over here on the right. Yep. And with this document ID, you can then use that again within our API to fetch the full document and get the context if you wanted more than just a single chunk. Great. So that is the core basis of how you can then build a search agent to then first build the searches, organize the information, and then pull that information into a more detailed agent architecture, which I'll pass back to Aakarsh to then talk about.
Right. So thanks a lot, Alex. That was a really good demo. I can tell you that everything that I'm showing you today, I actually used our MCP server live within Cursor to help me code, because I myself forget a lot of our syntax and the actual method signatures. So moving on from, there is an MCP server for our docs page right now. Within the next few weeks to a month, I think we're going to launch our MCP servers for our actual API queries. So if you do want to just include the big data tool in any choice that you have, Claude, OpenAI, etc., you will directly be able to call that get search results, and it'll actually respond back to you with actual documents. Now, what Alex walked you through is he asked Claude to write a file that can run a very specific search and give a very specific response for that search. If you're actually developing these systems in production, you want a system that can actually do it organically. So what we will do in the second half of this webinar is I'm going to walk you through a LangGraph implementation of what we're kind of doing behind the scenes, even for our own DeepResearch Agent. This is not a production level code, but it should get you enough that you could launch something very similar in your own environments with your own large language model of choice. The approach we're taking for our first webinar is how do you run a complex web search plan in an organic way using all of the big data API endpoints that we have. So what I'm going to walk you through here is an agent that I wrote up, which is You like provide the exact same search string, or you can provide any arbitrary search string. Based on that search string, it will plan out a series of search strategies to answer the question that you have. For the start, I've created a few tools. So I have a new search tool, a transcripts filings tool, a universal search tool, and at the end of it, it will compile a report up that looks very similar to the DeepResearch Agent. Now, I have not created a React agent yet. We're going to launch a series of like webinars where we show you how to create a planner agent, a React style agent, et cetera, et cetera. But the primary aspect here is if you can build a really powerful search strategy, you can use that as a subgraph in a larger graph system. And I'm using the graph analogy because we're using LangGraph for this example. This this repo is available on like GitHub right now. Adelaide will share a link at the end of this webinar where you can download and actually run it. Just to really quickly show you like what this README is. So what I'll be walking you through like today is a LangGraph workflow implementation. This is a like linear workflow where the searches are like running in like parallel. I'll be walking you through a prompt we've created that allows LangGraph or the search planner to invoke and call certain tools with certain types of like parameters. At the end of it, we will combine that with our hybrid search. It'll do slot filling and it'll live print out a response the way you would expect a chat style response to stream. The other thing that I found really interesting is LangGraph has this notion of you can send updates back to the front end for each step of the process. If you like remember the DeepResearch like demo that we showed you, we show you at the end of each step what it searched for, which sources were cited in that search chain, plus the reflection. So there are specific components that we've built that I'll quickly show you. And at the end of this, you should be able to modify it. Let's get started here. So I'm just going to drop this off. On the left-hand side, you'll see that there's a folder called the Bigdata Search Agent. The primary way to understand what we're doing here is we build abstractions on top of the Big Data Search SDK. So the first abstraction is this utility function. Now, the reason we created the utility function is we have a lot of clients that call our API 100 times per minute. I think our current rate limits are about 500 per minute. The way we authenticate is we use JWT tokens. So essentially, a really simple way of explaining that is you instantiate a client once, and then you use that same token to run each and every subsequent API call. All of the methods that are in this file show you exactly how to do that. The other thing, and it's called like a singleton pattern, but it's essentially allows us to run asynchronous calls using a single token. The other thing that we did here is we've created 4 functions called news search, transcript search, like filing search, and universal search. I've also created a like big data knowledge graph async. Ideally, what I would do is, and I'll show this to you in a subsequent like webinar, which is how do you extract the company name from a query or the entity name for a query, pass that to the auto suggest, return back an entity ID, and insert that entity ID in a search chain. For now, though, I'll just quickly walk you through what a news search async operator can look like. So let me just scroll down to where it is. Okay. So like the new search tool or the new search like function takes a list of search queries. So you can pass it a list of search queries. You can like define how many results you want back for each of the search queries. We have a historical point in time archive, which means that you can specify either like date ranges or you can do things like find me all documents within the last 9 months or 1 year or 3 years, etc. You can also do last 1 hour, last 5 minutes. You can pass it a list of source IDs. And this is important because we have a lot of clients that want to limit their searches to high quality sources. So we have the ability for you to specify these are the premium sources that I subscribe to. These are the web scrape sources which I want you to search through. You can actually pass those source IDs in, and the searches will be limited to that. The other three parameters are entity IDs. Alex just walked you through a key part of the search experience we have is you can inject entity IDs, and we only find you chunks that map to those entity IDs. The biggest utility of this is if you have tested out our watch list search on the Big Data app, it quite literally runs searches for each of the entities inside a watch list. So you can have a portfolio and say, find me all relevant news related to my portfolio. It'll find the entity IDs and it'll search for that. And then the last one is the re-rank threshold. The re-rankers are really important if you want high quality, relevant like documents back. Now, I've done the exact same thing for transcript search, and I've done the exact same thing for the filing search. You'll notice in these like methods, this slight amount of difference here. In a filings or a transcript search, we have these additional parameters that we've added. So you can specify what type of filing you want. You want a 10K, a 10Q, an 8K, and we're adding more and more as we onboard more content. You can specify the exact fiscal year or the fiscal quarter which you want for the filing. And we have this notion of reporting entity IDs. This is interesting because either you can run a search for find me the documents that contain like Micron as the company inside that document chunk. But you might also want to run searches where find me the document that Micron has like published related to its filing. So a reporting entity ID is the like where all of the document chunks belong to that entity ID. A entity ID, not a reporting entity ID, is the document contains information related to that company. It's a small difference, but it's actually pretty important. Immediately after this, I have these LangGraph tools. I'm not sure if everybody here is familiar with LangGraph, but essentially they make it really easy to like customize any kind of function, and you can wrap it up in a tool with a description. If you have used the MCP servers and stuff, this is a very similar type of idea. In an MCP server, you say, give me which tools you have available. Those tools have a description, and then based on the description and the parameters, the LLM will try to slot fill. This is a very similar type of approach that LangGraph takes. You can bind tools to a graph, and I'll show you that in 1 second. So all I've done here is I've just abstracted out the function calls that do all the async operations and all of that interesting work. And you just get these really simple tools with a bunch of parameters, which hopefully should be very easy for a large language model to call. I've done the same thing for the transcript search, and I've also done the same thing for filing search. Now, let's actually run this and see what we've done. I use UV.
Nope, you're not.
Oh, sorry.
In the terminal. There you go.
1 second. Yes. So UV run Python, Big Data Search Agent, streaming like example. So I've created a like file which will show you a similar type of response that you just saw from the DeepResearch Agent, except this is using the CLI. So it's going to run, and I'm just going to quickly walk you through what it's doing here. It's this exact same search, which is write me a deep dive report on how demand for memory is expected to grow. It's the exact same thing. Now, the search strategy, and I'll walk you through it in 1 second, is essentially saying it needs to run a news search, a transcript search for Q1, Q2, like 2025 insights. It's going to run some filing searches. It's going to run another transcript search, so it wants to grab like more context. It's also coming up with its own search queries. As you can see there, each of those queries are here. And just like you would get in a chat style interface, this is live streaming tokens back to your UI, or in this case, it's your CLI. At the end of its entire token writing exercise, I'll print out a pretty markdown file so then you'll be able to read it, and then we can compare and contrast the actual information. And there you go. So what did it just do? Let's just walk through it, and then I'll go into the details of the technical natures of the graph and the prompts. So I was able to generate a research report, which is about 2,700 words. And the context, oh, it's still doing the final workflow, but it's about, 600,000 characters.
Oops.
Oh, is that too small?
I was trying to zoom in.
Yeah, but then the formatting goes off.
All right, fine.
So I'm sorry if you cannot fully read it right now, but I promise you it reads really well. I will walk you through it. And then all of this is available on the GitHub repo. I really hope you guys try it out. But you get information that the LLM has now responded with just related to news. So it's only grabbing the news sources, and all of this information here is around news. After that, it's also looked at all of the transcript information. So it's now found specific bullets for related to that query that I ran just for transcripts. At the bottom here, you're seeing it also ran the exact same search on filings. And what I found really interesting is, and this is something we geek out about a lot, is it's really helpful to get a timeline when you're asking a large market style report, because it gives you a lot of context into the history of what the firm has said related to the search query. And they got all of this information from our historical archive. So it just grabbed a bunch of information related to dates and the memory market and Micron's role in it. And as you can see here, most of these things are also cited. We'll be adding some more functions here to help on the citations. And at the end, it has this really good, easy to understand summary. So this also completed. As you can see, it had 5 separate search strategies. The average content length, so the context that I fed the LLM, I think I'm using 2.5, Gemini 2.5 Flash here. It was 580,000 characters, and all of this completed in 117 seconds. This is not designed for a low latency system. There are large parts of this that we can make really fast. The actual search probably took only 4 or 6 seconds, FYI. All of the different searches done in ASIC. So how do you actually get to this response? I'm going to clear this terminal, and I'm going to do the same thing in debug mode, because I want to show you basically the magic that we've seen that actually happens to get high quality search results is in your search strategy, and how you craft a lot of the parameters that you want to send to your search strategy. So I just ran this search again, and the second time around, the LLM has decided to go balls to the wall, and it came up with all of these other queries, and it wants to do a lot more to go and find it out. This is normal. It is a non-deterministic system. I'm going to let it run these 6 searches, and in debug mode, I stream back the actual parameters that were used to fill. So I'll show you those parameters, and then I'll kind of walk you through how I use the graph and these parameters to come up with these answers. So here's what it did, behind the scenes, right? So the first search strategy was, I need to find news and management commentary on AI's impact on memory demand, blah, blah, blah. It came up with these 5 queries, and the parameters that it actually sent to the tool is it said, I'm looking for recent information. So it slot filled last 90 days. It picked the 30 results for each query, and those are the queries that it actually passed in. If you look at the transcript search here, it did a slightly different set of 5 queries. It picked earnings call as what it wanted to search for, and then it specifically said, actually, just go look at the management discussion and the Q&A section. If you change the query and say, what did analysts say about it? It'll go to just the Q&A section. It won't go to the management discussion section. And here it picked like the fiscal year 2025. On the filings, it actually went to the 10K from 2024. So it picked last year's 10K. And it also picked the most recent like 10Q. It's pretty cool. It's able to like discern based on your request, where exactly should I search? What are the parameters that I need to actually fill in? And it'll try to run a whole bunch of searches in like parallel in like parallel in order to fill in the context. It also ran another transcript search for 2024 earnings calls. There you go. Okay, so it did a bunch, right? It just wanted to go scan everything else. I'm going to quickly, I know we're running out of time. It's 2:37. Adelaide's giving me a look. So what you should just take away from this is what the search node in a like multi-graph system would look like. It will generate a search plan. It should execute on a search strategy. It needs to gather and collate all of your search results, and you want it to compile a final report. Each one of these steps are fully customizable, and you can actually get very, very creative with this. I don't want to go into this entire doc here because it's a lot, but I'll just start at the end because that's really how LangGraph works, which is these are my 4 nodes, and I can chain together these nodes in either a like linear fashion or in a parallel fashion. And the magic that we've seen is actually like LangGraph uses server-side streaming events. So you can define a writer and you can get LangGraph to send back responses like status updates, tokens, what is the search strategy that you use? It's completely up to you. So when you're designing a user interface, you can get really creative of saying, how do I keep my users engaged? And you want to stream back information to the user for each step. I've also added a whole bunch of tests here. So if you want to see what a new search can look like or a transcript search can look like, I'll just quickly run it here and then we can move on to Q&A. Let's just do that again. Create new terminal, UV run Python, test and test transcript search. And this is a really quick test, which is like running for like just like Tesla. And all I wanted to show you is these are the different types of searches you can run. You can like run a search with an entity and a date. You can run a search with an entity and a fiscal period. You can run a search with an entity and a similarity query. You can combine all of them together. You can say, just give me a search for the like reporting entity only, or I only want similarity search. I don't want anything else. This like customization actually enables a lot of different workflows because sometimes you want to see what people are talking about Tesla. Sometimes you want to see what Tesla is saying about itself. So with that, that's the end of our brief like webinar. Hopefully this gives you some color into how you can build a lot of these agents. Adelaide, if you can, please, there's a link which is available here. You can go and download this package, and I'll pause right there.
Perfect. I'm sharing the link right now in the chat. Okay, well, guys, thank you so much for showing us what's possible with the Bigdata.com API. The audience had some questions, and please keep them coming in the Q&A window. If you have anything else we don't cover with this. But let me start with, how does this integrate with existing model infrastructure? If I already have Claude or ChatGPT-4 deployed internally with compliance approval, can I route specific query types to those models while using big data for search? Who wants to take that one?
Yeah. So what we just showed you here is a LangGraph style agent. In fact, if I can just quickly show you here. So I have a configuration file where I am actually like defining the planner model and the writer model. You can customize this to anything that you'd like. You can use a local model, or LangGraph has wrappers for every known like large language model. So you can just change where you want it to point, and this thing should just work. So it's very easy to customize it for any approved and compliant models that you have within your own enterprises.
Perfect. Just this has come through a few times. Yes, the webinar is recorded, and we'll share a link following the webinar. For the second question, so we have in the deep research response, do the search only collect data from internal sources or also from the internet? Is it possible to map which part of the response comes from which internal document or external, hence the internet source?
That's a great question. Yes, absolutely. And I'll show you how exactly. So I went crazy with the search prompt. I think you can do too, but like this search prompt is the search parameter prompt, which is how do you customize where to actually look? I'm going to ignore this right now, but if you want your response to look however you'd actually want it to look, that's actually in the result like compilation. So if you only wanted to look for news for certain things and you want to customize your output to be like, this is my news section, if I'm understanding the question correctly, and this is my filing section, you can just insert the search context in this prompt. And in fact, if it's something that there's like more interest, we can show you how to really create a fully custom like report generation where you specify the specific sources which you would like. With our source IDs and our source like taxonomy, we make it dead simple to select what to actually run for what type of query. It's more like we have given our users, I think, a lot of flexibility, sometimes too much flexibility, but it's very easy to do because everything is configurable.
Okay, thanks, Aakarsh. We have one on the entity similarity search. So what is covered in entity similarity search?
I'm happy to cover that one. So those are two separate things. So if I jump back to the knowledge graph here, too many tabs. There we go. Perfect. So when we run a search, we have query filters. Yeah, also in here. So every entity that we talked about within the RavenPack knowledge graph. So entities includes companies, people, topics. Yeah, sure. Companies, people, topics, ETF, organizations, places, each one of these is mapped to a specific RavenPack identifier. These are unique identifiers for every single entity. Now, just as Aakarsh was saying, you could run an entity search on itself, and this will find all documents that you specify. So it could be a competitor that had a filing that then, let's say, mentioned Tesla. It will then still find that filing, find that information, find who was talking about Tesla and what did they say. So you can specify that and you can run just an entity search based on your filters. Now, a similarity search is slightly different, where a similarity search is where you're running a search for a specific string that you're looking for. So let's say you want to find, okay, who is talking about, in this case, South Korean elections, but we could also, let's say, who's talking about impacts of tariffs. And then we could remove the entity from that and just perform a similarity search across 100 million documents and find which documents and related companies are talking about impacts of tariffs. You can also then, what we find is very powerful is combining those two different concepts and putting them together to do what we call hybrid search, which is then performing a search of, okay, I have a list of entities that I want to look at, and I maybe have a list of concepts or themes or things that I want to scroll through. So maybe I'm just focused on, companies in the consumer space, and I want to talk about, okay, how are retailers talking about impacts of tariffs? That I would do by confining to a set of entities. I might actually do that with a watch list, which gives you a set of entities. And then I would then also add to that a set of strings that would be the similarity parameters. And I would run them in parallel together to then get this to get to specifically what I'm looking for. Because if you just run one or the other, you might end up with an enormous amount of results, which might be more than what you're looking for.
Thanks, Alex. I think just to continue on the entity search, can you walk us through how the entity resolution actually works? When I search for Tesla, how does the system actually handle the complexity of Tesla Inc. versus Tesla Energy versus Elon Musk versus supplier relationships?
Yeah, so our background is we have been doing entity enrichment for 20 years with our traditional quant product. So behind the scenes, what we have is we do have a graph of all known entities, their units and subsidiaries, their related products, etc. The way the system works is inside each document chunk, we enrich the lowest entity in a node. So if it says model Y, it will return back the entity ID for model Y. We provide our clients with either Snowflake, or you can use it via the auto suggest Snowflake tables, with a relational model that you can essentially map all the underlying entities to the parent entity. So that's the core part of the system that at the base layer, we have all of the known entities that we would detect. Our system automatically does the resolution of the underlying entity to any of the related entities which it has. And that's kind of we call it 1 degree of separation, 2 degree of separation away. And it's very easy to resolve it with either the knowledge graph, or you can use the auto suggest tool and it'll do the same thing for you.
Thank you. Okay, we have line. What is your chunking strategy? Is it changed with new context flexibilities provided by new LLMs?
It's a great question. When we first designed the chunking of the system, this was in 2023, we tried going all the way down to a sentence level. We tried going all the way up to a document level, and we found a sweet spot, which is it is an intelligent chunker, and a chunk is generally less than 512 tokens. What we found is using the embedding models available at that time, at least, that 512 tokens gave us the best bang for recall and relevancy of search. Have we experimented with larger chunks that I know a lot of the new embedding models will support? Yes, we have. What we have realized though is that going down to our amount, the chunk that you will get, the 512 tokens, still gives us the most bang for buck on recall. So we have a whole bunch of eval sets that we run and train the search system on. All of that, that's kind of the sweet spot that we found. So
yeah,
I don't know if that answered the question, but it's an intelligent chunking strategy where each document is normalized to 512 tokens or less.
And you can fetch the chunks just before and afterwards.
Yes.
If you wanted to add longer context, you could easily do that in how you query the API.
Yeah. So if you wanted to so it's one thing to find the right information related to the chunk, but if you want to pad context for the LLM, we make that very easy because we give you a chunk ID. So you can quite literally just retrieve the chunk before and after, or we give you the document ID and you can pull the whole document and pass that into the LLM.
Thanks, guys. Okay, another question. What is the embedding model you are using, and can a user change that model?
The embedding model we are using is a custom fine-tuned sentence transformer that is 384 DIMs. And no, the user cannot change that model because it's essentially when you upload stuff into our vector database, everything is hyper-tuned, including the re-ranker models are hyper-tuned for financial domain relevancy. So in our current approach, you're uploading documents or you're using any of the predefined sources that we have. These things are pre-embedded. And for paid clients that want access to the embedding models, we also make that available. So it is a custom tuned sentence transformer with 384 DIMs.
Perfect. Okay, so how accurate is the research coverage for frontier and emerging markets where news data for securities are not a lot?
It's a very good question. Like, let's say we are we have we are currently talking to 68 like different providers all across the world to onboard their content. For example, for Chinese content, we're now working with Kaiksin Global that has excellent Chinese coverage. We had so many Middle East clients that wanted excess coverage on Middle East, so we're launching our new Middle East package. We support 13 different languages, so and we're expanding it now because with LLMs we can support 100. My short answer to that is we have coverage for 100,000 like public companies where we're really good. If there are gaps in our coverage, you can give us a ping, and we have an entire like division dedicated to onboarding more content. So we are constantly going out and bringing more content and offering it up as packages to our clients.
And actually, I mean, a good example, I was just going through last week, the different content sources and testing out our newly launched content filter or source filter. And we were able to generate similar reports, but then looking at the same topic, but how is that seen through the lens of, let's say, Chinese news media, Iranian news media, and Western news media? So you can get multiple perspectives on the same thing by running the same pipeline with different content source filters.
Okay, perfect. I think maybe one more question here. Yeah. How would you position this against just using OpenAI's function, calling with Bloomberg API or FactSet feeds? What are we getting here that we can't build with existing tools?
It's a great question.
Yeah.
Have you used the FactSet or Bloomberg API feeds? Because I'm an ex like FactSet person, by the way. I have nothing but very, very good things to say to the company. I tried building this at like FactSet as well. All of their APIs are document APIs. So if you try to use it and you run a search, you will get a document ID back. For a single transcript, that's about 8,000 tokens. If you try to run a search across 100 like transcripts, you will quickly run out of context. So a big like differentiator is we have one single normalized schema for every provider that we onboard. So it doesn't matter if it's Bloomberg, it's fact. Like we work with FactSet. We don't work with Bloomberg, but we work with FactSet and we have their content in. So it's one like normalized schema for every single source that you get. Every single like document chunk that you get back is enriched with reference data. So we actually give you guarantees that you can sort of map back. And then there's so many functions that we've added and ways of querying the system that as you start using it, I think you will find us more than happy to compete with them. But I think you will see that we give you a much more differentiated offering than them. When it compares to OpenAI or Perplexity, we run into this all the time. They have incredible search tools. So I don't want to say that they don't have good search. We have search with reference data. We work with premium partners. So we give you licensed and gated content, such as, like Midnight Trader, FactSet content, Middle East markets, Crypto Wires, Al Jazeera, CNBC, Kaiksen Global, Washington Post. These are all things that we have, and we're onboarding expert like network transcripts. We're onboarding podcasts, and you can select and filter in all of this. I don't think any other tool does the same thing exactly.
Okay, do you guys have one more question in you?
Please.
What kind of latency and throughput can we expect at scale? If I'm building a system that needs to handle hundreds of portfolio managers running concurrent research queries, what should I plan for in terms of infrastructure?
You don't have to worry about anything. Our like largest client today is 7,000 analysts that are using it every day. Our like rate limit today is 500, but it's just like 500 per minute. To protect our system, we can scale that out to about like 10,000 per minute pretty easily. There is an example here. We actually use our own tool to run millions of searches for our like thematic, like workflow. So here is a cookbook of how you can run a million like searches in 3 minutes for the Russell 1000. So scale and latency is like not a problem. And also because we're a high frequency quant trading like system, like that's our bones. We process documents in 200 milliseconds, and we try to get it inside the index in under 1 second after it gets published.
All right, awesome. Okay, well, I think with that, big thank you to Alex, Aakarsh, everyone that joined us today. I've shared the GitHub repo link in the chat where you'll find all the code from today's demos and everything you need to start building agents. If you don't have a Bigdata API username or password, please contact us at sales@ravenpack.com and we'll get your account set up. Yeah, thank you so much for joining us and see you very soon.
Great. Thank you all for your time and attention.
Appreciate it.